Welcome back to Three Inquisitive Kids. In this lesson, we will be learning about the properties of proportional linear functions. Chapter 4. Understand the rules of the graphs of proportional functions. This is part 1 of properties of proportional linear functions. So in the next lesson, part 2, we will be learning about linear functions, but here we're going to be just looking at proportional linear functions. Learning goals. Understand the concept of function graphs and master the general steps of graphing functions. Grasp the properties of proportional functions. Let's do some review first from the last lesson where we learned all about proportional functions, what they are, and their properties. So among the following four equations, which ones are linear functions and which ones are proportional functions? Well, 2 and 4 would be linear functions, and number 2 would be proportional functions. Proportional function. Remember, proportional functions are just a type of linear functions. 2. What are the representation methods of functions? Well, we can use graphs, tables, or the relational expression form. All 3 of these methods can be transformed into each other. So for example, if you have a graph, you can turn it into a table or into an expression. If you have an expression, you can transform it into a graph or a table form. If you start with a table form, you can turn it into the expression form or the graph form of a function. Now, can you convert the relational method into the graph method? This is what we're going to be looking at today. So can you turn the relational expression of a function into its graph form? Graphing proportional functions. Example 1. Graph y is equal to 2x on the coordinate plane. Well, we start with the table method. The top column would be x, the value of x, and the bottom column would be its corresponding y value. So let's start here with x is equal to 0. When x is equal to 0, y would be 2 times that, which is also 0. If x were 1, y would be 2, because 2 is equal to 2 times 1. So y in all of these pairs is always 2 times larger, 2 times bigger than x. So this is our table method. Now we have to look at the expression method. Okay, so here what we have done is we have turned this relational expression of the function into the table method. We turned the expression method into the table method. This is the first step to graphing a proportional function. And then what do we do? And then we have to plot points. This is step 2. So we can use the coordinate pairs in the table as the coordinates of a series of points. And then we plot these points on the plane. So here's the coordinate plane. And we're going to pick out at least 2 coordinate pairs from the previous table. That's going to help us create this graph. So one of them so they're all along here. And then we connect. That's number 3. Connect, and this is the graph of that function. And a lot of the times when we do graph it, we usually write that relational expression next to this graph so we know what is this function that we're talking about. So the key point summary is the steps to plotting proportional linear functions. We start by turning that relational expression into a table. Its table form would be just listing out the x values and their corresponding y values. And then we use the pairs from that table as the coordinates of each point. So we would plot those points, and then we would connect them on the coordinate plane. Graph y is equal to negative 3x according to these steps. Well, here would be the final version of y is equal to negative 3x, its graph form. So as you can see here, it's also a straight line. It crosses through the origin point. It's just that it's a little different because instead of increasing, it's decreasing. So just make observations about this and think about what we're going to talk about next relating to this scenario. What similarities do both of these functions share? So you can just quietly think about that, what you observe, what applies to both of these graphs. Conclusion. So first we have the proportional function form, which is y is equal to kx, where k is the constant and k is not equal to 0. So this right here, y is equal to kx, is a straight line passing through the origin. So here are our observations. This would be y is equal to kx, where k is not equal to 0, and this column would be the quadrants that it is passed through. So when k is greater than 0, the graph will pass through quadrants 1 and 3. So what I'm talking about here to review, see this is the coordinate plane, right? This would be quadrant 1, 2, 3, and 4. And when k is less than 0, the graph will pass through quadrants 2 and 4. And it makes sense, because first of all, we know it is a straight line that passes through the origin, meaning it can only pass through 2 quadrants. And when k is greater than 0, k here is the constant, which is the coefficient of that variable. It makes sense, because this means that k is positive, meaning the slope is increasing. And when k is less than 0, it means that the slope is negative and it is decreasing. So it would be here and here. Since 2 points determine a straight line, we only need to find the points 0, 0, and 1k when graphing proportional linear functions. What this means is, since there is an infinite amount of coordinate pairs that can go on a graph of a function, of a proportional linear function, we only need 2 points to determine the straight line. Because remember, a line is determined by 2 points. You need a minimum of 2 points. So these 2 points, the easiest ones to get are often 0, 0, because we know proportional functions have to go through the origin, and 1k, where k is that constant value in the function. And then you can just connect these 2 points and get the graph of the function. So this would be the easiest way in order to graph proportional linear functions. Draw a graph of the following functions in whichever way you prefer. So we have y is equal to negative 3x and y is equal to 3 over 2x. Well, here, when in this first function, when x is equal to 0, the y value is equal to 0. When x is equal to 1, the y value is equal to negative 3. And in the second function, when x is equal to 0, the y value is equal to 0, but when x is equal to 1, the y value is 3 halves. So now let's plot these points down on the plane. We have the origin here. So this is for y is equal to negative 3x. Connect. And then we have y is equal to negative 3x. And then we start with the origin as well. 3 halves. And then we connect. So this would be y is equal to 3 halves x. Given that y is equal to m plus 1 times x to the m to the squared power, given that this is a proportional function, what quadrants does it pass through? Well, to solve this problem, you need to apply the properties of proportional functions and its definition. So because we know it is a proportional function, then m squared has to be equal to 1, because if it's a proportional function, it's a linear function. And if it's a linear function, its independent variable, can only have a power of 1. So m squared has to be equal to 1. But we also know that since it is a linear function, its coefficient cannot be equal to 0. So m plus 1 cannot be equal to 0. Therefore, m is equal to 1. M plus 1 is equal to 2. Because we know m is equal to 1, 1 plus 1 is equal to 2, which is greater than 0. So since it is greater than 0, the slope of this function is greater than 0. We know that the quadrants that it passes through is 1 and 2. So the quadrants that it passes through would be 1 and 3. That is a typo right there. Quadrants 1 and 3. Step up 1. We know that y is equal to k plus 1x is a proportional function. So if the function graph passes through the quadrants 1 and 3, the value range of k is blank. And if the graph passes through 2, 4, then k is equal to blank. This first one right here, you have to give it inequality. The second one here, you have to give a value, a number. All right, so analysis. Because the graph passes through the first and third quadrants, k plus 1 is greater than 0. K plus 1 right here is the coefficient, and the solution is that k is greater than negative 1. So that is the answer to the first question. If the graph passes through this point right here, then k has to be equal to 1. Because when we substitute 2, 4, this coordinate pair, into the relational expression of this function, we are technically solving for k. And solved k is equal to 1. So 1 is the answer to the second question. Step up 2. When x is greater than 0, the relational expression of the function of y and x is y is equal to 2x. When x is less than or equal to 0, the relational expression of the function is y and x, which of y and x is y is equal to negative 2x. The graph would roughly look like what? Okay, so here we know when x is greater than 0, this is what the graph looks like. So it means that on the right half, the positive half of the x-axis, it would look like y is equal to 2x, meaning that the slope is positive and going upwards. So just by looking at that piece of information, we can eliminate B and D because neither of those have a increasing slope on the positive half of the x-axis. Okay, and then when x is less than or equal to 0, the relational expression of the function of y and x is y is equal to negative 2x. So when it is less than 0, it would have to have a negative slope. So C would be the correct answer. And also you could eliminate A because that is not even a function. A and B are not functions because one x value cannot have two y values. That's something we emphasized in the past 2 lessons. So the correct answer would be C. The properties of the graph of proportional functions. Graph. Plot the proportional functions y is equal to x, y is equal to 3x, y is equal to negative 1/2 x, and y is equal to 4x in the coordinate plane. Graphed, they would all look like this. So in these 4 graphs, as x increases, how does the value of y change? In the following functions, how does y change as x increases? Well, when k is greater than 0, as x increases, y increases as well. When k is equal to 0, we said the slope is positive. But a more specific way to describe that would be as x increases, y increases. Another way to say it is y increases as x increases, same thing. But when x is less than 0, as x increases, y decreases, where we would be saying the slope is negative. So for example, y is 2x would roughly look like this on the coordinate plane, where this is 1, that right here, and 2. So this first coordinate pair is 1, 2. So notice how this function right here is moving to the right and upwards. So becoming greater and greater on the positive halves of both the x and y axis. And also, if you look at these coordinate pairs, as x increases from 1 to 2, y also increases from 2 to 4. So that's what it means when we say as x increases, y increases. But when k is less than 0, for example, when y is equal to negative 2/3 of x, it roughly looks like this. And you'll see as the value of x increases, so from negative 6 to negative 3, the value of y decreases from 4 to 2. So it's going smaller and smaller on both the y and x axis. Well, no, it's decreasing as its y value, but increasing in its x value. So our conclusion is, in a proportional linear function, y is equal to kx. When k is greater than 0, y increases as x increases. But when k is less than 0, y decreases as x increases. Let's do some more practice. 1. If the graph of y is equal to kx, where k is greater than 0, passes through the points x1, y1, and x2, y2, and we know that x1 is less than x2, then y1 is blank y2. What is their size relationship? And for number 2, if proportional functions y is equal to k1x and y is equal to k2x are graphed as shown, then the relationship between k1 and k2 would be blank. Pause the video and fill in the blanks by yourself. The answer to the first one would be less than, because when k is greater than 0, x and y changes. So when x decreases, y decreases. When x increases, y increases. So if x1 is smaller than x2, we know y1 has to be smaller than y2. In this next one, the correct answer is A. Example 3. It is known that the graph of proportional function y is equal to mx passes through the point m4, and the value of y decreases as the value of x increases. Find the value of m. Well, because this function passes through m4 and it is a proportional function, it also has to pass through the origin 0, 0. Therefore, 4 is equal to m times m, solved m is equal to positive or negative 2. Because remember, negative 2 times negative 2 also works. And since y decreases as x increases, we know that m is less than 0. So m has to be equal to negative 2. Discuss. In proportional functions, y is equal to x and y is equal to 3x. As the value of x increases, the value of y increases. But which of them increases faster, and can you explain why? And in number 2, in proportional functions, y is equal to negative x and y is equal to negative 4x. As the value of x increases, the value of y decreases. Which of them decreases faster, and can you explain why? Well, in the first one, which one would increase faster? The one that would increase faster would be y is equal to 3x, because this second function right here is tripling the speed of the first function because we times a 3. This is its slope. So here the slope would be 3 and the slope would be 1. So with every increase of x, for the first function, y would also increase 1. But in the second function, whenever x increases 1, y would increase 3, meaning that y is equal to 3x would increase faster. And here, which one would decrease faster? Decreasing faster means which one has the greater slope. We know they're both negative slopes, but which one has the greater, steeper slope? That would still be the second one. Y is equal to negative 4x. Because in the first one, as x increases by 1, y decreases by 1. But in this other function, as x increases by 1, y decreases by 4, quadrupling the speed of change as the first function. So the larger the absolute value of k is, the steeper the graph is, and the closer the graph is to the y-axis. Class summary. Today we learned all about the properties of proportional linear functions. The steps to graphing proportional functions: table, plot, and connect. You first create a table to list out all of the coordinate pairs, plot 2 points, 0, 0, and 1, k, and then you connect them. Graph, a straight line passing through the origin. When k is greater than 0, it goes through the first and third quadrants, and when k is less than 0, it goes through the second and fourth quadrants. Properties. When k is greater than 0, y increases as x increases, and when x is less than 0, y decreases as x increases. The first skill we learned today is to understand the concept of function graphs and master the general steps of graphing functions. The second skill is grasp the properties of proportional functions, so in describing the rate of change that they're going at. Thank you so much for watching through Inquisitive Kids, and if you would like to be notified when we upload this part 2 to this lesson, be sure to click the subscribe and notification bell down below, so you will be getting a notification as we upload that next video. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.